All right, today we are going to be talking about the exterior angles of a polygon. So we start with the exterior angle conjecture. Okay, now for any polygon, any of them, the sum of the measures of all exterior angles. Okay, so again, the exterior angle sum means all of the exterior angles added together is going to be 360 degrees. Doesn't matter if I'm talking about a triangle, a square, hexagon, dodecagon, a 100-sided shape. All of the exterior angles in that shape add up to 360 degrees. Okay, notice here I have the exterior angles extended out, the 120, 120, 120, right? A triangle can only have 3 exterior angles. Okay, 120 plus 120 plus 120, guess what? They add up to 360. Then if you notice our quadrilateral, 90, 90, 90, and 90, 90 plus 90 plus 90 plus 90, guess what? They add up to 360 degrees. Right? Now, it doesn't always have to be a regular shape. It can be an irregular shape as well. These, I just have regular shapes as examples. Okay, 72, 72, 72, 72, 72. Guess what? They're all going to add up to 360 degrees. That's for exterior angles only. Hence the exterior angle sum conjecture. Next, this part probably should have been part of 5.1, but they throw it in 5.2. We already kind of did this part. So this is saying you can find the measure of each interior angle of any equal angular polygon, right, by using these two formulas. Now, we already did this. Remember how we had our total interior angle sum, and then we divided by how many sides there were to find the singular one. So that's kind of what we're doing here. Okay, so if we have, let's say, for example, a square, okay, we know that squares add up to 360 degrees, okay, and we divided by 4 because we had 4 sides, so we got 90 for our angles when it's equal angular or a regular shape. So we can use these two formulas. Okay, you can kind of pick which one looks better to you. I think the second one is a little easier to understand. It's up to you though. 180 minus 360 divided by n, or 180 times n minus 2, that should look familiar because that's our polygon sum conjecture, and then divide it by how many sides there are. And that's essentially what we did. We took the interior angle sum and then we divided it by how many sides. Okay, for a pentagon, we knew the angle sum, this part in blue here, was 540, and then we divided it by 5, the number of sides. Okay, so we already filled out each part here. This is what this part right here is what that last conjecture was referring to. Okay, so we said that in a equal angular triangle or equilateral triangle, each angle would be 60. In a regular quadrilateral would be 90. In a pentagon, 120, and then you guys filled out the rest. Now, let's see who is paying attention here. The exterior angle sum, the sum of all the exterior angles in a triangle, what do they add up to? How about for a quadrilateral? What does the sum of the exterior angles? How about a pentagon? How about a hexagon? Heptagon, octagon, nonagon, decagon, all of any shape, the exterior angle sum is always 360. Now, what if we just wanted one exterior angle? Right, we take 360 and divide it by how many sides we had, right? And we get 120 for our exterior angle. Then we do the same 360 divided by 4, and we get 90 degrees. 360 divided by 5, so we get, I believe, 60 degrees. Okay, double check and continue the rest of the table. So your entire table should be filled in at this point.